Hi everyone, it's the Math Sorcerer here with Chegg. In this video, we're going to discuss new functions from old functions. Let's start with an example. Sketch f of x equals negative x squared plus 4. Let's work through this solution. So because we have an x squared as part of the function, what we're going to do is basically start with the graph of x squared and then shift it and reflect it to come up with this answer. So recall the graph of y equals x squared is hopefully familiar. It looks something like this. Here's the x-axis, here's the y-axis, and it's basically a U, and it opens up like this. It's called a parabola. So if we look at negative x squared, what happens there is you get the same graph, but it's upside down. So this would be the graph of negative x squared. And then when you go to negative x squared plus 4, you basically take this graph and you go up 4. The final graph in this case is going to look like this. So here's the x-axis, here's the y-axis, and it's up 4. So it's going to be up here at 4. And then it just goes down like this and goes down like this. It crosses the x-axis at 2 and negative 2. And you can tell because if you plug those numbers in there, you're going to get 0. So this is the graph of f of x equals negative x squared plus 4. So a couple things we use in this problem that I'll just refresh your memory on. So in general, if you have a function f of x and you put a negative sign in front of the function, you're going to reflect across the x-axis, okay? And so in our particular case, our f, even though it says f up here, but our f that I'm applying this to is x squared, because we had negative x squared, and so we reflected it across the x-axis. And if you have, say, f of negative x, so a negative in front of the x, you're going to reflect across the y-axis. So there's a trick to memorize these. If the negative is in front of the y, you reflect across the x. If the negative is in front of the x, you reflect across the y. So you reflect across the other one. As far as this step here, whenever you add something to the entire function, you go up. If we had subtracted, we would have gone down. Let's do another example. In this example, we are going to sketch g of x equals the absolute value of x plus 3. Solution. So we're going to start with the graph of the absolute value function, which is y equals the absolute value of x. So here's the y-axis, here's the x-axis, x, and y. And this graph has a really interesting shape. It's basically just a V that looks like this. So the absolute value function looks like a V. Now we need to figure out what's happening here in this particular problem. We're adding 3 to the x. So it turns out that whenever you add a number to the x, it's left. You think it's right, but no, it's left. In this case, we're going to go left 3. We're going to take our graph here, and we're just going to shift it to the left by 3. I'm going to draw it again over here. Here's the y-axis, here's the x-axis, so x and y. And here we have 1, 2, 3, put a dot, and that will be our absolute value function right there. So we just draw it like that. Notice it crossed the y-axis. So to find the y-intercept, what you do is you plug in 0 for x. So g of 0 is equal to the absolute value of 0 plus 3, which is the absolute value of 3, which is 3. So maybe just put a dot there and put a 3. So that's it for this one. I should emphasize, though, just so you know for future problems, let's just do a couple more examples of shifting so you make sure you got it. So let's say we had the absolute value of x minus 2. In this case, you're subtracting from the x. So in this case, you want to go right 2. And if you had the absolute value of x and then the plus 2 on the outside, in this case, it would be up 2. If you had the absolute value of x and then a minus 2 on the outside, in this case, it would be down 2. And of course, if you had the absolute value of x and a plus 2 on the inside, it would be just like our example here. In this case, it would go left 2. So this is extremely useful to know and quite helpful when doing these types of problems. But honestly, more important than any of this is just knowing the general shape of the absolute value function. The absolute value function is a V. Okay, let's do something else. In this last example, we are going to look at a different way of combining functions called function composition. So we have f of x equals 2x plus 3, and g of x equals x squared plus 1. And the question is to find FOG of x. So let's go ahead and work through it. Solution. So by definition, this new function, which is called FOG, it has the following formula. So FOG takes x and sends it to f of g of x. Whenever you see FOG of x, it's f of g of x. Every time you see a parentheses, you say of f of g of x. So now what we do is we start with the inside piece. So g of x is x squared plus 1. So this is f of x squared plus 1. So all we've done at this point is just replace the inside piece here with g. This is equal to, so now we're looking at f. F of x is equal to 2x plus 3. Instead of x, we're going to replace the x with x squared plus 1. We get 2 parentheses x squared plus 1 plus 3. And so this is equal to, distributing the 2, we get 2x squared plus 2 plus 3. It ends up being 2x squared plus 5. And that would be the answer, 2x squared plus 5. Basically, you just start by replacing the inside function with what it is. In this case, it was x squared plus 1, and then plugging in x squared plus 1 into your function f of x, which is 2x plus 3, and then going from there. And this is called the composition of two functions. Hopefully you've learned some math in this video, and if you enjoyed this video, make sure to check out more videos on Chegg. Good luck.